04:15 hours, August 9th, 2025. A lone Ukrainian drone slices through friendly airspace. Its mission, a one-way trip to Russia's largest military drone factory, a facility producing 500 drones per month that bleed Ukrainian cities. In 10 hours, it will be over the target, poised to change everything. But first, it must survive the next 30 seconds. The drone crosses a Ukrainian air defense position. No IFF transponder, no data link, no identification. Just a steady flight path, the signature of a Russian attack. The Gepard's radar locks on. Twin 35mm cannons swivel, tracking the contact. The fire control computer calculates the intercept solution. 8 kilometers. The operator stares at his scope. The target matches a Bayraktar TB2 profile. The Russians had captured TB2s before, turning them against Ukrainian forces. One struck near Bakhmut using this same approach profile. His finger hovers over the fire button. At this range, tungsten rounds would shred the drone in seconds. Then he remembers the midnight briefing. From 0420 to 0430 hours, withhold fire on any target at 150 meters altitude, plus or minus 5. Flying 150 kilometers per hour, plus or minus 10, through this exact corridor. No explanation was given, no context provided. His watch shows 0419, 1 minute until the window opens. 4 kilometers and closing. The fire control shows a 94% hit probability. Every instinct is screaming to engage. The system tracking it is a Ukrainian Gepard SPAAG, a self-propelled anti-aircraft gun with its twin 35mm Oerlikon autocannons. It can unleash 1,100 rounds per minute, each shell holding 152 tungsten sub-projectiles. The ammunition airbursts at a set distance, creating a lethal cloud precisely in the target's path. No drone could survive that tungsten storm. 8 kilometers. The fire control computer was already calculating the solution, but something felt wrong. Ukrainian drones launch at night for dawn strikes. Not at 0415. They fly high to clear friendly fire, not at 150 meters where any gun can reach them. 7 kilometers. Radar paints it clearly. A 12-meter wingspan. A twin-boom configuration. Definitely a Bayraktar. Or what he assumed was a Bayraktar. He knew Russians had turned captured TB2s against them before. One had hit near Bakhmut just last month, using Russian flight patterns. But this contact maintained Ukrainian approach protocols while heading for Russian territory. 6 kilometers out now, the drone flew as if on rails. There were no evasive maneuvers like a recon drone would make, no altitude changes to avoid detection, and no electromagnetic emissions at all. At 150 meters, every Russian position will see it the moment it crosses the lines. An exposure profile that made no tactical sense. Unless the drone had no plans to return. 5 kilometers, 0420 hours. The window is now active. The operator's hands are tense on the controls. If this is a captured Russian TB2, he has only seconds left to stop it. If this is a Ukrainian mission, he will destroy it. The fire control computer shows a 94% probability of a kill. 4 kilometers. Optimal range in 5 seconds. Every fiber of his being screams to engage, but the parameters matched perfectly. Exactly 100 meters, exactly 150 kilometers per hour, exactly down the specified corridor. Through his optics, he could now see the drone. This was not a TB2, but a 1196 Lyutyy drone. This meant only one thing. The Lyutyy passed overhead at 0426. And the operator watched it disappear. Russian territory now lay directly ahead. Morning reports would soon cascade through enemy command structures about a lone drone that could not be stopped by 0 to 600. For 30 hours, Sector Command in Bryansk had received 3 anomaly reports. Border posts reported the same contact. A slow-moving drone, 50 meters altitude, heading 087. It was unresponsive to electronic challenges, its course unwavering. The tactical display showed a direct vector toward Nizhny Novgorod. Beyond that, the projection continued straight to Alabuga. The duty officer gave the order, deploy the Pole 21 to to grid reference 445892. The system you see here is the POLE-21 GPS jammer. It is a mobile broadcasting tower fixed to a military truck. Its 15-meter mast radiates 1,000 watts of electronic noise on both GPS frequencies. It creates a 20-kilometer bubble where satellite navigation ceases to exist. Its signal strikes drones at -90 dBm. Real GPS whispers at -130 dBm. That is 10,000 times stronger, like hearing a whisper beside a jet engine. The AN-196 entered the jamming envelope at 0634. The operator watched his scope, counting the expected sequence: 3 seconds for jamming to overwhelm the receiver, 5 seconds for the drone to recognize signal loss, 10 seconds to initiate lost link protocol, usually circling or returning home. At 8 seconds, the drone wavered. A tiny wobble as its INS tried to compensate for the lost GPS. At 10 seconds, it should have turned. It did not turn. It steadied and continued east. The operator switched to spoofing mode. Now, the POLE-21 wasn't just jamming. It was broadcasting false satellite signals designed to convince any GPS receiver it was 500 kilometers from its actual position. The drone should have corrected toward this phantom location, flying off course to fuel exhaustion. The target ignored the false signals completely. Analysis of its flight path revealed something sophisticated. The drone wasn't just following the railway, too predictable, too easy to ambush. Instead, it was using multiple terrain references. Follow the M3 highway for 10 kilometers. At the S-curve near Seltzow, adjust heading 15 degrees north. Track power lines until they intersect the river. Cross at the 3-span bridge, not the 2-span. Each waypoint was chosen for its uniqueness. Impossible to confuse. Visual navigation meant complete autonomy. No GPS to jam, no control to override. The Russians had spent $8 million per POLE-21 unit. Thousands of engineering hours perfecting GPS denial. Ukraine had defeated it by teaching a drone to look where it was going. The alert went to the Nizhny Novgorod S-400 battery. Drone inbound, ETA 0945. A preliminary warning was sent to Alabuga. Possible drone incursion, confidence moderate. Arrival estimated at 1150 hours. By 0800, Russian electronic warfare operators were tracking a ghost. A drone navigating precisely through a GPS blackout, following highways and rivers like a tourist with a perfect map. Each checkpoint brought it closer to Alabuga, where 5,500 Shahed drones waited in warehouses before their deployment over Ukrainian skies. At 0945 hours, the S-400 battery near Nizhny Novgorod had been tracking anomaly reports for 3 hours. Brask had lost a GPS immune drone headed their way. Now their radar would find it. The system is the 92 N6E Gravestone radar, the S-400's eyes. Those panels hold 10,000 transmit-receive modules, pumping out 100 kilowatts of focused energy in the S-band 2 to 4 gigahertz. Against a fighter-sized target with a 3-square-meter radar cross-section, the detection range reaches 250 kilometers. But radar physics are brutal for small targets. The AN-196 presents only 0.5 square meters, 6 times smaller than a fighter. Detection range does not drop linearly. It follows the fourth root of the radar cross-section ratio. That math collapses detection from 250 kilometers to just 107. First, the drone flew at 50 meters altitude, using the Earth's curvature as a shield. At 0945, the drone climbed to 200 meters to clear terrain. The radar locked on immediately. Slow-moving UAV. Bearing 262. Range 89 kilometers. The classification was certain. A 12-meter wingspan, twin-boom design. It matched the profile of a TB2 Bayraktar. But the location was impossible. A Turkish drone's range is 300 kilometers. This contact was 900 kilometers from Ukraine. The timing was a critical vulnerability. Shift change at 1000 hours. The night crew had 13 minutes left, their focus already fading. The day crew wouldn't be combat effective until 10:15. This was the gap, a 15-minute window where no one would make the hard call. The track was a razor-straight line toward Alabuga, not a wandering recon pattern, not the search behavior of surveillance. This was a clear attack run. This was direct navigation to a target. And here, the S-400 and Pantsir relationship became critical. The S-400 engaged long-range threats with its 48 N6DM missiles, $2 million a round, reserved for high-value targets. The Pantsir offered close-in defense with its 30mm autocannons and smaller missiles. The systems are networked, sharing data, creating a kill box of overlapping fire. But this integrated defense had one geometric flaw. The Pantsir's cannons cannot depress below -5 degrees. At 4 kilometers out, 50 meters high, the angle needed was -7. The drone was flying underneath the gun's effective range. The expensive missiles were doctrinally reserved. The cheap autocannons couldn't reach it. The contact dropped back to 50 meters, disappearing into the ground clutter. This is radar's blind spot, its inherent weakness. A storm of false returns from trees, buildings, and terrain, flooding the screen with electronic noise. The radar operators see a wall of static where Earth meets the sky. The drone vanishes into the electronic chaos. The overnight supervisor makes his log entry. Possible UAV contact, bearing 087. Assessed as reconnaissance. Lost in ground clutter, no action taken. By 10:15, as the day shift reviewed the log, the Lyutyy was 40 kilometers past their station. The new operator scanned his scope. Nothing. He dismissed it as morning thermals, a common false return. The warning to Alabuga was updated. Confirmed drone approach, high confidence. Estimated time of arrival, 1150 hours. Multiple systems had failed to engage. At Alabuga, counter-drone teams prepared. They possessed purpose-built systems designed to succeed where traditional air defense had failed. But they weren't counting on something unique. A Ukrainian innovation. At 11:47, Alabuga's station had been tracking the threat for hours. Baransk reported GPS jamming failure at 0630. Minsky Novgorod logged contact at 0945. Now it was here, 8 kilometers out and closing fast. Climbing through 250 meters, a direct approach in broad daylight. This system is the designated Repellent 1, purpose-built to kill drones. Its antenna focuses 500 watts into a 30-degree cone designed to overwhelm any receiver within 2.5 kilometers. The system's computer holds 10,000 command protocols. Every frequency, every standard, every known drone override command. Turkish military frequencies, NATO standards, Ukrainian protocols, even commercial Chinese codes were included. The operator engaged. 500 watts of electromagnetic energy slammed the drone, cycling 10,000 commands in 4 seconds. Return to home, land immediately, enter hover, switch to manual, emergency stop. Every override, transmitted in every format. The drone flew on, straight, level, unchanged. The next attack, mechanical frequency hopping. The system targeted specific frequencies at microsecond intervals, an attempt to catch the drone between signal hops. Even encrypted systems can glitch if you hit the right frequency at the right microsecond. This tactic had defeated jamming-resistant drones before. Still no response. 5 kilometers and closing. The Surf S5 GPS spoofer joined the assault. It broadcast false satellite signals at -100 dBm, 1,000 times stronger than authentic GPS, creating a phantom location 500 kilometers away. The spoofing signal shifted, a standard tactic to force a turn. It was a proven countermeasure. The drone held its course. Range, 3 kilometers. Analysis of its flight path revealed a chilling truth. It was navigating by sight, following the main road to the water tower. It adjusted at the railway junction, corrected at the river bend. Pure optical navigation, comparing the ground to stored images. And that wasn't the worst part. Inside the drone, key systems were gone. The sensor ball, removed. The satellite dome, stripped. The antennae arrays, severed. Extra fuel tanks were welded where equipment should have been. The control receivers weren't just disabled, they had been physically removed. Antenna cables were cut and capped. All radio modules were gone. There was no RF pathway into the drone's flight computer. They were trying to hack a drone with no connection to hack. All stations, barrage jamming. The order was given. 14 jammers opened fire. An electromagnetic storm erupted from 100 megahertz to 6 gigahertz. 50 watts per megahertz of raw noise. Enough to crash a processor by induced current alone. But the drone's computers were shielded, wrapped in aluminum Faraday cages. They felt nothing. The processors kept running, completely isolated. Waypoint 1146 achieved. Proceeding to waypoint 1147. Initiate terminal dive at 1152. High noon. The AN-196 hit the anti-drone mesh at 180 kilometers per hour. The steel grid, built for 5-kilogram quadcopters, tore apart against 700 kilograms of aircraft. Its thermite warhead breached the warehouse roof. The chemical reaction was instantaneous. Iron oxide and aluminum. The result? Iron, aluminum oxide, and 2,500 degrees Celsius. Molten metal streamed onto the Shaheds. The first tank ruptured in 0.3 of a second. Fuel vapor expanded 8,000 to 1, creating immense overpressure. 2 seconds, 50 drones exploded in sequence. 8 seconds, the roof failed under 3 atmospheres. 15 seconds, the north wall blew outward. 30 seconds, all 500 Shaheds were consumed. The fireball climbed to 800 meters. The shockwave shattered windows 5 kilometers away. 6 months of production, $500 million of technology vaporized in under a minute. One drone proved that in this new age of warfare, sophisticated defenses were just expensive systems shouting at an enemy that could not hear them. And it was only the beginning.